Good evening, dear students. Welcome to Ekeeda India Private Limited. We are going to start. We are going to start today the torsion of circular shafts. I am teaching strength of material for GATE exam competition point of view, and today we will solve some questions of GATE exam. So let us start our topic. First of all, have a brief idea what is the torsion of circular shaft. What we mean by torsion of circular shafts, right? So let us have a shaft. Circular rod is considered to be a shaft if a torque is applied on it. The force applied at certain radius is called torque, which is trying to twist this shaft. This is the torque applied on the shaft, right? Torque applied on the shaft. So we will discuss the formula first. What are the formulas to be used here? And then we will proceed with the questions, right? What formula we will use? We will not derive the formula because the formula is already derived in our theory lectures. So in theory lectures, we have already derived the formulas. And here we will discuss the basic concept and the formula. Just you can revise or remember these formulas, right? So first of all, we have to find out what is torsional equation. It is very important topic, that is torsion equation. We are not going to derive this, but you should remember that torsion equation is given by T by J equal to tau by R equal to G theta upon L. T by J tau by R G theta upon L. This is our torsional equation. Torsional equation. T by J tau by R and G theta upon L, right? So here T is the torque applied. This is the applied torque. What is J? J, that is polar moment of inertia. Polar moment of inertia. In theory lecture, we have also discussed what is polar moment of inertia. This is polar moment of inertia. And the value of this for circular shaft is, suppose the dia of the shaft is D. If the diameter of the shaft is D, the J is given by pi by 32 d to the power 4, right? I hope that you know this thing, that this is given by this equation, pi by 32 d to the power 4. Tau is the shear stress. Shear stress on shaft material at different radius, right? And R is the radius at which we are finding the shear stress, right? Radius. In this case, we are taking the outer radius of the shaft, right? So when we are taking the radius of the shaft, at the radius of the shaft, tau will be tau max, right? Maximum torque will be there at the radius of the shaft, outer radius of the shaft, right? G is the modulus of rigidity, right? And theta is angle of twist, and L is the length of the shaft. L is the length of the shaft. Isn't it? So we have these quantities, the torque. I think there is some lack of clearance is there, so should increase. I will take a pause. So there may be some network issue. That's why it is not clear, but somewhat it is clear. So this is the torsion of the shaft. So we have seen that there is the torsional equation of the shaft. This is the torsion equation of the shaft we have seen. What is the concept behind that is that when we apply the torque, there is a twist at certain point. Suppose this is A point and this A point will be twisted to point B. This A point will be twisted to point B and there is some angle of twist theta, right? So this is theta angle of twist. If we see the side view of this, this is the initial center and this is the angle of twist, right? So this is the angle of twist which is very important, that is from A to B, right? And the shear stress in this case, we have already discussed in theory lectures, is given by the linear variation, right? At center the shear stress is 0 and shear stress varies linearly from 0 to maximum, right? So this is how the shear stress varies. This is how the shear stress varies, right? So shear stress varies in this way, right? So this is the variation of shear stress, and shear stress will be maximum at the outer fiber. This is tau max. Shear stress is maximum at the outer fiber, right? And 0 at the center. At the center point, the shear stress is 0, right? So this is the concept of torsional of the shaft, right? And when the torque is applied, so power is transmitted. So how much power is transmitted? So power transmitted. So P is given by 2 pi n t upon 60, right? Where n is the RPM of the shaft, right? So n is the RPM of the shaft, right? So now one important formula from torsional equation. From torsional equation we can find out torsional equation. We know that torsional equation is given by T by J g theta upon L. From here we can find out that theta, if we use this equation and this equation, if we equate these two equations, we can write that theta will be equal to TL upon Gg, right? This thing you have to remember. That theta will be given by TL upon Gg, right? This is very important. Angle of twist. This is called angle of twist, right? So you have to remember this formula. This will be used widely in our numericals, right? So power is 2 pi nt upon 60. Angle of twist is TL upon Gj. Another thing is shear strain. There is straining of the material from A to B. So this is called shear strain. This, which I am making with black, this is called phi, is shear strain. So phi here is shear strain, and this is given by, in basics you have to go there, that shear strain is given is the ratio of shear stress upon modulus of rigidity, tau upon G. So this is the ratio of tau upon G. This is shear strain, right? So these are the formulas which will be used here. And J, already we have discussed that J will be given by pi by 32 d to the power 4, right? For solid shaft. For solid shaft. For solid shaft, right? For hollow shaft, J will be given by, for hollow shaft, for hollow shaft, for hollow shaft, the J will be given by pi by 32 d to the power 4 minus d to the power 4, outer dia to the power 4 minus inner dia to the power 4. This formula you have to remember this, right, for hollow shaft. So we have discussed shear strain, shear stress, torque, power transmitted, angle of twist, and the polar moment of inertia for solid shaft and hollow shaft. These things we have discussed, right? So let us move ahead for the numericals. We can discuss now the numericals, right? So let us have some numericals on this. Yeah. Let us read this numerical. A torque T is applied at the free end. At the free end, this is the free end. This is called the free end. Free end. One end is fixed and other end is free here, right? So a torque T is applied at the free end of a stepped rod. Why we are calling it a stepped rod? Because dia is changing. Here the diameter is 2D and then it is reduces to single D, right? So that's why it is called stepped rod of circular cross section as shown in figure. The shear modulus of the material of the rod is given to us G. The expression for D, we have to find out the value of D. D we have to find out. This D we have to find out. To produce an angular twist theta at the free end, theta is given to us. Angle of twist is given to us theta, right? And the options are given to us. So how to solve this question? Very simple and very important question. This question was asked in GATE 2011. So how to solve this question? Let us see what is happening here. If we see the side view of this figure, there is a small circle of this diameter D, and then there is a large circle of diameter 2D. So two diameters are there, D and 2D, right? And there is angle of twist, and there is some angle of twist theta, right? So this is the angle of twist theta, right? And theta is given to us. Theta is given to us. D we have to find out. What is the diameter, right? G is given to us in terms of G only, right? And T, torque is also given to us. Torque is also given to us, right? These values are given and some values are, we have to find out. D we have to find out, right? So theta, if we divide this shaft into two parts, this is a one part and this is the second part of this shaft. Two parts are there, right? So there is some angle of twist in this part, theta 1. Some angle of twist is there, theta 2. So in series connection, this shaft is in series connection, right? Stepped shaft is there. So we can say this is a series connection of shafts. And in case of series connection of the shafts, the total angle of twist at the free end will be equal to the angle of twist in the first shaft plus the angle of twist of the second shaft, right? Because there is series connection, so angle of twist will be added up, isn't it? So this is similar to the bars, two bars. This is similar to two bars which are connected in series connection and a load is applied P, right? So in this case, the total deflection in the shaft will be equal to delta L1 plus delta L2, right? So this is the total deflection in the shaft. So we can compare this with this. a uniaxial loading, right? When a load is applied axially, right? So this is compared with this, right? So similar to this, the angle of twist will be theta 1 plus theta 2 in this case also. So we have to find out the total angle of twist, right? That will be added up. So total angle of twist will be theta 1. What is theta 1? Theta 1 will be equal to, torque is T applied, torque is T. So T, length of the rod is L upon G. G is the modulus of rigidity of this shaft, G, and J. J is the polar moment of inertia of this shaft, right? J, or J1 we can say. And what is J1? What is J1? That is pi by 32, pi by 32, 2d to the power 4, right? This is J1. Now theta 2, what is theta 2? That is equal to torque T multiplied by length. Length is L by 2, L by 2 here. So this is L by 2 upon G and J2. And what is J2 then? J2. So J2 will be equal to pi by 32 d to the power 4. And total angle of twist will be, theta will be equal to theta 1 plus theta 2. So that will be equal to TL upon G. So total angle of twist will be given by, theta will be equal to TL upon G, and J is pi by 32 2d to the power 4 plus T, length is L by 2 of the second shaft, divided by G is same, and then this is polar moment of inertia, that is pi by 32 d to the power 4. Solve it. We can take some quantities outside. T, L, and G can be taken outside. There is some values obtained here inside the bracket, and then we can find out. Just a solution is required now. Mathematical form is obtained now. So now we can solve this, and you will get the answer of this question as, I'm writing the answer directly. You can solve it. So from here, D can be taken out. D can be taken on one side, and the answer can be obtained as D will be equal to, so I'm writing the answer finally. So D will be equal to 18 TL upon pi G theta to the power 1 by 4, right? Solve it and you will get this answer, right? So this is the answer of this question, isn't it? So inside the bracket, you will get some value. Inside the bracket, you will get the value as L can also be erased here. I am writing the previous step also so that you can solve it easily. So this will be equal to L by, L will be there, pi by 32 2d to the power 4 plus L by 2 divided by pi by 32 d to the power 4, right? You can solve it and you'll get this answer, right? So this is which answer? This is B answer. So answer B is correct. D can be taken out on one side, and this is the answer. So this is the answer of this question, right? So this is how we solve the torsion questions, right? So let us take one more question. Let us take this question. Consider a stepped shaft. Stepped shaft. Again, there is a stepped shaft. Consider a stepped shaft subjected to a twisting moment applied at B. The twisting moment is applied intermediately at B point. You can see here 10 Newton meter is applied at point B, right? And Assume that shear modulus G is given as 77 gigapascal. The angle of twist we have to find out, right? In degrees. Theta we have to find out in degrees, right? This we have to find out. So how to solve this question? How to solve this question? Now, it has two parts. It has similarity with the simple stresses case, that when a bar is applied, suppose we have a bar, we can compare this question with the our simple stress questions, like a bar is there and this is a stepped bar and an axial load is applied here. Axial load is applied here. Suppose P load is applied, right? What will happen with this? What will happen? And we have to find out, suppose, the deflection. We have to find out the deflection of this shaft, right? Delta L, we have to find out the total deflection. So total deflection will be equal to delta L1 plus delta L2. Total deflection will be delta L1 plus delta L2, right? Similar to this case, if this is one shaft and this is two shaft, and we have to find out total deflection theta, so that will be equal to theta 1 plus theta 2, right? But in this case, if we divide this shaft into two parts and see what is happening, what are the load applied on these shafts, you can see here the reaction. If the P load is applied in this direction, for static equilibrium, same load should be there, same reaction should be there, so that the body may be in static equilibrium. So P load will be there, P reaction will be there, R should be equal to P, reaction should be equal to P. And for static equilibrium, here is also the load should be P. And if this is so, if we have applied the load P at B point, it means that there is no load at B point of this second part of this beam, right? So here there is no load, zero load, and here also zero load, right? It means that delta 2 is 0, because there is no force applied on two part, right? It is freely hanging, just it is free, so no load is there. So in this part, actually there is no load, and if there is no load, there is no deformation of this part. It means that delta L will be equal to delta L1 only, right? Similar to this case we have discussed here, the torsion of shafts will be followed by the same concept, right? That the angle of twist theta 2 will be 0, because there is no torque on this part. The torque is only on this part, and there is reactionary torque. There will be a reactionary torque on this 10 Newton meter. So if we divide this into two parts, this is 10 Newton meter. So there again, there will be a reactionary torque 10 Newton meter on one part, and the second part is free, and there is no torque applied on this part, right? So torque applied is zero torque, isn't it? Zero torque applied. It means that total angle of twist is basically theta 1 only, right? Because this end is free and no torque is applied, similar to this case, which we have taken for simple stresses, right? So theta 1 we have to find out. Basically theta 1 will equal to T1 L1 upon G1 J1. So this will be equal to T1. What is now T1? Torque, that is 10 Newton meter. L1, length of this shaft, that is 500. Length of this shaft is 500. L1 is 500 and L2 is also 500. We need only L1, that is 500 millimeter, divided by G. G is modulus of rigidity, shear modulus, that is 77. Gigapascal you can convert into megapascal. And then J1, that is pi by 32 d to the power 4. What is diameter? Diameter is given 20 mm, right? So 20 to the power 4. Solving it, you will get the angle of twist as, final result I am writing here. The angle of twist for this case will be given by 0.236, 0.236 degrees. So this is the answer to this question. So this is the answer of this question. So let us consider one more question of GATE exam. I hope that this question is clear. This question was asked in GATE 2015. Okay. So let us have this question. A rigid horizontal rod of length 2L. The length of the rod is given as 2L, right? This is L plus L. So it becomes 2L. So total becomes 2L. Is fixed to a circular cylindrical radius R. The radius of this shaft is R, right? So this is the radius. Radius is given as R. And vertical forces of magnitude P are applied. Vertical forces are applied, right? It means it is forming a couple, and this couple will produce a torque on the shaft, right? When the load is applied in this way, this is 2L and this is P, so it becomes a couple, and this will be equal to, and it will produce torque on the shaft, right? So this torque will be equal to P multiplied by 2L, right? You know that one of the load multiplied by the distance. So the torque applied on this shaft will be, P into 2L. So this is 2LP. At two ends, as shown in figure, the shear modulus for the cylinder is G. Shear modulus is given to us, and the Young's modulus is E. Young's modulus is given. The vertical deflection at point A is, we have to find out what is the deflection of this point A. Vertical deflection, where this A point will move, right? So we have to find out the movement of this A point, right? Suppose this point A moves from this to here point, right? A dash. So we have to find out this deflection, this vertical deflection. So we have to find out, say this deflection is Y. So we have to find out this Y, which is A dash in this case, right? This vertical deflection we have to find out in this case, right? So how to solve this question? How can we solve this question? So let us proceed. Yeah. So what is the torque? Torque we have already found out. Torque will be equal to P multiplied by 2L. So this will be equal to 2PL. This is the torque. So torque is obtained to us, right? So torque we have to find out. So if we want to find out the moment, vertical moment of this point A, suppose this point A moves from here to here. Say this is point A dash. This distance, vertical deflection is Y. This Y we have to find out. So we can make a diagram. This is a right angle triangle like this. This is a right angle triangle, and this is the angle of twist. This is the theta of this triangle, theta, right? So suppose this is O point. So we have a triangle now. We have a sort of triangle here, not right angle triangle, but there is a triangle here like this, and this is theta, right? And this is length is L. Length is given to us L. I will make it much clearer like this. and this is the deflection theta. This angle is basically the angle of twist. This theta is basically the angle of twist of the shaft. Angle of twist of the shaft, right? So this is theta and this is L. This length is L. And y we have to find out, right? So if this is so, in that case, what is angle of twist first? First we have to find out the angle of twist theta. How to find out theta? So theta will be equal to, you know that theta is given by TL upon GG. This is our formula, TL upon GG, right? Torque we have already found out. What is torque? That is 2PL, because the P is applied in the form of a couple, and total length on which this couple is applied is 2L. So torque will be 2PL, right? So this is 2PL. What is L? Length. Length of this shaft is L only. This length L. What is G? G is given to us. This is G only. And J. What is J? J is radius of the shaft is given, right? So we can write pi by 32 2r to the power 4, because radius, the answer is in terms of radius, right? Answer is in terms of radius. That's why we are writing here 2r to the power 4, because diameter of the shaft is equal to 2r, right? That's why we have written 2r to the power 4, right? So angle of twist will be equal to T, which is 2PL multiplied by L is a length, upon G is as it is, multiplied by pi by 32 2r to the power 4, right? Solving it somewhat, you can solve it and you will get theta as, I'm writing after solving, 4PL square upon pi G r to the power 4. This is the angle of twist, right? And because this angle is small, so y can be written as, y will be equal to L theta, right? It is similar to that S is equal to R theta. In a circular path, if the angle is small and if this is R, this is S, so S will be equal to R theta, right? S is equal to R theta. So similarly here y will be equal to L theta. So y can be written as, y which we have to find out is L theta basically, right? So solving it, you will get y will be equal to, theta is already obtained, so we can find out now the y. So that will be equal to 4PL cube upon pi G r to the power 4, right? So this is the value of the deflection, right? So this is the answer of this question, the value of y, this value which we have to find out, y, right? The movement, although there will be circular movement, but because this is very small deflection, so that's why we can say this is a vertical movement, right? Small vertical deflection of this A point in upward direction from A to A dash, right? So what is the answer? 4PL cube pi G r to the power 4. So answer D. So answer is basically D. D is the answer of this question, right? This is the answer, isn't it? So this is how we solve the question of torsion of circular shafts. Let us have one more question. We have already discussed that before solving this question, we have discussed that what is shear strain. We have discussed that the shear strain is this angle. This angle we have shown the shear strain, right? This angle. There is some angle of twist here, but this angle which is corresponding to the length of the shaft, this angle is the shear strain, right? So this question is about the shear strain, phi. phi. Phi is here the shear strain, right? Shear strain. And what is the value of phi? You know that within elastic limit, stress is proportional to strain. Stress is proportional to strain, and when we open this proportionally sign, we will write g theta or g phi, right? So this phi will be equal to tau by g, shear stress upon modulus of rigidity, right? Shear stress, phi, this phi will be equal to shear stress divided by modulus of rigidity, isn't it? And it is dimensionless, and phi is dimensionless. Because shear stress and modulus of rigidity have same dimensions, right? So this is also Pascal, and this is also Pascal. So Pascal to Pascal cancel, so it is dimensionless, right? And we know the torsional equation. Torsional equation we already know. Torsional equation. What is torsional equation? That T by J equal to tau by R equal to G theta upon L. Right. So from this torsional equation, we can obtain the phi. How to find out phi from this torsion equation? So we know tau by g is phi. So from this equation, tau by r equal to g theta upon L. We are taking one part of this equation, right? So tau by g will be equal to r theta upon L. And from here, tau by g, what is tau by g? This is phi, shear strain. So shear strain will be equal to r theta upon L. So this is the shear strain, where theta is angle of twist, right? So this is how phi can be obtained. Now we can do this question, right? Based on this background, this question can be solved, right? So now we can read this question. What is this question? A cylindrical rod of diameter 10 millimeter and length 1 meter. Cylindrical rod is there. Cylindrical rod is there like this. It has a diameter of 10 millimeter, right? So diameter is given to us, it is 10 millimeter, and length is also given to us. So L is given to us, that is L equal to 1 meter or 1000 millimeter, right? If we want to use all the values in millimeter, right? So 1 meter is fixed at one end. This is fixed at one end. One end is fixed. So this is the fixed end. The other end is twisted by an angle of 10 degree. So this is twisted by an angle of 10 degrees. So this is there is an angle of twist, theta, right? And theta is given to us, that is 10 degrees. 10 degrees, right? This is angle of twist. But while using the theta in numericals, you have to convert it into, not in degrees, but you have to use it into radians, right? And you know that 1 radian is equal to pi by 180. So theta will be equal to 10 multiplied by pi by 180 radians, right? Whenever you have to use the theta in calculation, you have to use in radian, not in degrees. So by applying a torque is applied if the maximum shear strain in the rod is this much, P into 10 to the power minus 3, then what is the value of P? We have to find out the value of P. So shear strain is given to us. So given, what is given us? That shear strain P multiplied by 10 to the power minus 3, this is given, right? What is the value of P? This we have to find out. So to find the value of P, so what is the value of P? This we have to find out. So how to solve this question? We know that T by J, tau by R, G theta upon L, isn't it? Torsion equation we have already discussed. So from here, tau by G will be equal to R theta upon L. And what is tau by G? This is shear strain. This phi will be equal to R theta. Theta is the angle of twist upon L, right? And some values are given to us. That phi is P into 10 power minus 3. What is R? R, radius. Radius is, diameter is given 10 millimeter. Diameter is given 10 millimeter. So radius will be equal to 5 millimeter, right? So you can use the values in millimeter, so that millimeter to millimeter will cancel out, right, in R and L. So 5 millimeter multiplied by theta. Theta is angle of twist in radians. We have to use in radians. So this is 10 multiplied by pi by 180, right? This much radians divided by length. Length is 1 meter, which is equal to 1000 millimeter. So this is 1000 millimeter, isn't it? So now you can solve it. This will be cancelled out, and finally you will solve it and you will get the final answer. I'm writing the final answer now. Solve it and you will get the value of P as around 0.876. 0.876. So this is the value of P. This is the value of P. And round off to 2 decimals, so you can round off to 0.88, right? So this is the answer of this question, right? So these are some questions on the torsion of circular shafts. So if you have any doubt, you can send in chat box. I'm not able to see chat box at this moment. So this is all for today. We have solved some questions, and the next class will be on 28th of November on Saturday only at 8 p.m. only. We will take one more topic, bending stresses and shear stresses. So we will solve questions on that for gate questions, right? So okay for today. Good night.